Another great way to see the process of TCP when you're sending data is to use Wireshark directly and then examine it. So if we look at this Wireshark packet capture that I have, so I did a packet capture in Wireshark. I went to go get to my website, danscourses.com, and I hit capture, and then I stopped the capture. And so then this is that conversation. This is following that TCP stream. So first I filtered for HTTP, found the beginning of my request to danscourses.com, and then right-clicked and did follow TCP stream. And so we can see the stream here. Now let's take a closer look at it. So there is the SYN coming from my computer to my web server. The response, a SYN and an ACK. Notice the relative sequence numbers here. Sequence number 0, this is a 0 and a 1 for the SYN and an ACK. And then my response here with an ACK 1. So you can see the three-way handshake right here. SYN, a SYN and an ACK, and an ACK. Then the next thing that happens is my computer makes an HTTP GET request. So with this GET request, if we drill down into the TCP or the transport layer here, we can see random source port, the destination port 80, and you can see here this is sequence number 1, ACK 1, and if we look at the flags, and this is pretty interesting, this request not only has this ACK 1, but it also gets a push flag set because this is the end of the request. There's not going to be any more, I'm not sending any more data. This is the complete request. So don't buffer or don't put this into a buffer and wait for more information. This is the end right here. So you see the ACK and then the push. And that's right here, the GET request. So then after we see that, we see the responses coming from the server. So if we look at the response from the server, this is from the server to my IP address. This is the beginning, and we can see here the window size is 30,464. You can see sequence number 1 and ACK 582. Now, why is that? We'll take a look here, and we'll see here that in the previous GET request, the size, the length of the segment, the TCP segment length was 581. It was the first segment that my client sent, and the next sequence number is 582. So in other words, the length was up to 581, and then the next sequence number would be 582. So when the server responds, it responds with its own sequence number 1 and an acknowledgement 582, because that would be the next sequence number in the series. However, the client's not going to send any more requests. It's just going to be now the server sending the data to the client. So at this TCP segment here is where the server starts sending back to the client. And as you can see, it's going to send to the client 1, 2, 3 times before it gets an acknowledgement from the client. So you can see here, there's the 1, 2, and 3. And if we look at them, we'll see on this first one, the sequence number is 1, but the segment length is 0. So it seems like there's no actual data here. The next one, the sequence number is still 1, but we have a segment length of 1460. And then the third one, the sequence number is now 1461, the segment length is 1460, and the next sequence number or the acknowledgement that we'll be expecting will be 2921. When my computer sends the acknowledgement back to the server, you can see that the acknowledgement here is 2921. And that's the relative acknowledgement number. It's not the actual 32-bit sequence number that's been incremented by 1, but the relative sequence number that's been incremented by 1. And so there's the ACK going back to the server. Then the server sends 1, 2, 3, 4, 5, 6, 7, 8 times before it gets a response. So you can see that that's a lot of segments going from the server to the client. Notice that the acknowledgement that there's an acknowledgement when the server's sending the client, but the acknowledgement always stays the same at 582 because the initial GET request was the the segment length was 581, and it would be, if there was more data to come, it would be 582 that it would expect next, but that's not coming because it's the server sending the data to the client and not response. The client just sends acknowledgments acknowledging that it's received it. So you can see here 1, 2, 3, 4, 5, 6, 7, 8. If we track through each one, we can see here the sequence number 2921, the length 1460, the next one 4381, the next one 5841, the next one 7301, all the way down until we get here, and this is the last one, the sequence number 13,141, and then it's expecting 14,601 from the client. When the client responds, which is all the way down here, the ACK is 14,601. And once again, that's the relative ACK number. And so at the acknowledgement, and then that goes back to the server, and then the server can start sending at 14,601. In the next segment, the sequence number should be 14,601, and it is. So it's kind of fun to look at this process right here in Wireshark. This makes it very tangible, or it gets you a little bit closer to tangibleness by actually seeing each of the packets as it crosses the wire, what protocol it is, what kind of acknowledgement is, the numbers of the acknowledgements and the sequence numbers, and how the conversation is being tracked by TCP from client to server.